Bonjour, Kinamage and Ireland Indigenous, and welcome to this Math Tier 2 intervention. Today's episode, Reteach 4.5. We'll begin by reviewing the answers to our last section from Lesson 4, Reteach Adjusting Quotients. You should be able to compare your answers with what is provided here. If there's any that you're finding difficulty with, it's advised that you attend the live session as it's during our regular school day. And these videos are intended for students who were absent for whatever reason. So on number 4, ended up 6, remainder 29, even though we might have started with a 7 and overshot it. The next one, we might have started with 70 into 380, but it would have still been all right. We had a 5, remainder 57. Number 6, 7 goes into, you'd probably start with a 7 anyway, but you ended up 7, remainder 55. And number 7, start with a 3 and we get 3, remainder 52. Number 8, we ended up with 6, remainder 80. So we had some pretty large remainders, and that's likely because they wanted you to have to think about the digit you were placing in the quotient. So let's go into today's lesson, dividing greater numbers. And I'm going to tell you right off the bat, there is no difference between dividing really big numbers and 3-digit numbers or 2-digit numbers. The steps will remain the same. You look and you say, well, how many times does each number go into the next? That doesn't change. Your steps of divide, multiply, subtract, compare, and bring down, those don't change. What does sometimes change when you have larger numbers is where you're placing that first digit in the quotient. So let's look at the document. You should have this out and ready with you. It says you can use a standard algorithm or a calculator to divide greater numbers. Calculators are all well and good, but that's not what I want you to use today. In the real world, yes, you will sometimes throw together, you'll use your calculator or one on a phone to quickly solve a problem, but that does you no good as far as knowing how to solve a problem. And that's what I want you to focus on today. If you want to check your answer at the end, using a calculator to multiply your final answer times your divisor and then adding the remainder to check and see if it's right, that part is okay. When we're using remainders, calculators are not actually all that useful because it will often give you a decimal for your remainder, which is okay, but not where we're at right now at this point of 5th grade. So we can estimate using compatible numbers, and we have here 12,420 divided by 365. And this is pretty close to 12,000, and this is closer to 400. So we decided we could take off these two. So 120 divided by 4 is 30. So we think it's about 30. So we'll take that first 3, and we're going to have to put it over this 2. Notice I didn't put it into 1. 3 digits don't go into 1. They don't go into 2. They can go into 3, but 365 is bigger than 124. So now we'll go into 1242. So really what this now stands for is 1,242 tens. So we put in the tens place. And then we had a 3 as part of our estimate, so we'll start there. Now once I put that 3 in the tens place, I multiply that times the divisor, and I get 1,095. I subtract, I get 147. 147 is smaller than 365. We bring down a 0. So now notice they put the 0 right next to what we had just subtracted. It's not underneath it, it's right next to it. And we have 1,470. Well, we remember that 3 times 365 was 1,095. So we wanted to go a little bit bigger because we can pretty much tell it's not going to quite work out. So we put a 4. And we get 1460 once we multiply 4 times the 365. Notice whenever we put a number up here, we multiply times the number out here. So times 365. It's always by the divisor. And they get us 1,460. We subtract, it's 10. There's nothing to bring down, and 10 is less than 365, so it becomes our remainder. So we end up with 34 remainder 10. And can we check our reasonableness? Yes. Now we could go ahead and multiply 34 times 365, which would give us just a little bit less. It would give us 12,410. We add the 10 on, we're good to go. But you probably can be checking reasonableness as you go along. And is it pretty close? 34 is close to 30. All right, so first estimate, then divide, check for reasonableness. I would like you to try each of these problems. I'm going to do one up here, and probably one down here. It says then divide using a calculator, round the quotient to the nearest whole number. Go ahead, you'll be allowed to do that in this instance. But normally I would rather you not try to go that route. So let's start up here. 62 does not go into 1 because it's a 2-digit number into a 1. It won't go into 18 because it's larger. So we're going to go into 189. I need my annotation tool. And this is close to 60, and 6 goes into 18 3 times. So let's try it. 3. 3 times 2 is 6. 3 times 6 is 18. I subtract. I got a 3. Notice I didn't divide 18,940 by 62. I just divided 189 times 62. And that's something to remember when trying not to kind of be panicked by these numbers. 3 was less than 62, so I bring down the 4. 62 will not go into 34. It's too big. So I put a 0 up here. 0 time, anytime you multiply 0 by anything, it's going to give you a 0. So I have 34, and I bring down another 0. And then how many times will 62 go into 34? I'm going to 6 times 6 is 36. That's too big. So let's try 5. 5 times 2 is 10. I'm going to put that down here, and I know I'm into other numbers, but you know what? We have an eraser. We'll make it work. 5 times 6 is 30, plus 1 is 31. And so we have 305, remainder of 30. Once you do your steps. So make sure you kind of written this in, and I'll give you a second while I grab my calculator to model the next problem. I'm going to attempt to do a new share here. So if I can move this to the side here, and we can see that I have the problem of 36,004. And I always recommend you double check your numbers before you hit it. The division symbol, 853, and that equals 42. Now, how do I round right here to the nearest whole number? Well, this is the last whole number because it's the last digit before the decimal point. So that's either going to be 42 or 43. So you look to the number to the right, and 2 is less than 4, so it'll stay 42. So we ended up with 42 right here. You weren't necessarily needing to go into the correct answer at that point. I would like you to complete numbers 2 and 3 and 5 and 6. Go ahead and use the calculator like it says for 5 and 6. It's not bad to have some calculator skills, especially in the real world, but it is still important that you know the standard algorithm. We'll be back in our next episode and review the answers as part of it. Hope you all have a mental geisha God. I'm a P.